background first of all. Yes, so let us just get rid of all these things. Okay, so what I will do is by simply let me take 8-bit 1 2 3 4 5 6 7 8. All the green color parts are actually 8-bit, that is 1 byte is equal to 8-bit. Okay, so I will just take this 0th bit, 1th bit, 2nd, 3rd, 4th, 5th, 6th, 7th bit. Okay, so what I will do is I will just center all these parts. So now if you see, we are having 0th bit, 1th bit, 2nd bit, 3rd, 4, 5, 6, 7. This is called as most significant, this is called as least significant bit. Coming to the most significant bit, already I told you to store 127, 7 bytes are required. So all this red color marked byte are enough to store 127. But why this is 7 is taken? This is taken for the sign, this is taken as a sign bit. So this 7 is acting like a sign bit. What is sign bit? If this bit is 0, then the number is taken as a positive number, and this becomes 1, then this is taken as a negative number. This is taken as a negative number. Okay, so we will check what will happen. First of all, let me take 127. 127 is there. What is the binary representation of 127? 127 binary representation, I think yesterday itself we saw, it is 7 ones. 1 2 3 4 5 6 7. So automatically your sign bit will be 0. That is telling that this is a positive value. And now what happens is, when you increment this 127 by 1, what will happen here? Bitwise addition will happen. How this is going to happen? So we will see here. Okay, so for example, just I'll just mark. So I'll just here come with the answer block also. Yes, fine. So I have to add it with only simply 1. When I add it with 1, what will happen actually? When 1 and 1 is added, it becomes 2, which means that it is like 10. When you do in bitwise addition, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, but 1 plus 1 is 10, which means that I'm going to keep the 0 here, right side part here, and I'll be taking the remainder carry here as 1. So 1 plus 1 is 10, 0 is taken here, 1 is taken as a carry. Now add 1 and 1. When you add 1 and 1, what will happen? Again it will become 0 and carry will be again 1. Similar will happen. So again what will happen? Again your number, again what has to happen? Again this will change to, wait 1 minute. So here again what will happen? 0. So again what will happen? A carry will be sent here to 1. Again 1 and 1 is added, you get 0, carry is 1. The same process again and repeating. So 1 and 1 added, again the balance becomes 0 and the carry becomes 1. Again adding both these things, it becomes 0, answer becomes 0 and the carry becomes 1. Again when you add 1 and 1, the answer becomes 0 and the carry becomes 1. That 1 is added with the sign bit and your sign bit becomes 1. When your sign bit becomes 1, what will happen? It becomes a negative number. What's the corresponding negative number? If you see this representation, what is this? This is 128. This is 128. If you see, I think I have already taught you how to convert a binary to a decimal. Go to that video, first video, and see what is the procedure of converting decimal to binary. So binary to decimal or decimal to binary. So convert 128, you will be getting 170s. So this is actually 128, as well as this 1 is acting as a sign bit also. So this is like minus 128. This is minus 128. That is the reason why when I am adding 1 to my 127, it is giving me minus 128. It is giving me minus 128. Yes, fine. So this is it for the part of overflow. I think now you understand what overflow will do. Overflow, what it will do, when a highest value is stored, when you increment it, it will go back to the lowest value. It will again go back cyclic to the negative value. Yes, fine. So the next thing that we will do now is we are going to see about the bitwise operators. We will be seeing about bitwise operators. Okay, we are going to see about bitwise operators. Okay, we are going to see about this bitwise operators. And what a bitwise operator, what are all the bitwise operators we are having? Let me list it out first of all. Bitwise AND operator, bitwise OR operator, bitwise XOR operator, and we have a bitwise NOT operator, and we have left shift operator, and we have right shift operator also. So we will see one by one, all these operators we will see one by one. So before that, what I will do is, first of all, these things I will just take it off. These are the bit numbers actually, so these things also we will just, let me take it off. Yes, fine. So what I will do is, actually we will just see the simple gate operations, and then we will just move ahead. Okay, fine. So okay, so what I will just see tell you is, I'll just include one more just one more row. I'll just, okay, fine. So now what I will do is that I'll just take bit 1, and I'll just take bit 2 also. Okay, and now for example, if I consider the bit 1 is 0 and bit 2 is 0, so combination of 2 means it is 0 0 0 1, and it can be 1 0, it can be 1 1. This is a combination of 2 bit actually. This is a maximum combination. So first of all, what I will do is, I will make an AND operation. What is the AND gate will do? What AND gate is going to do? So bit 1 and bit 2. What this will do? So bit 1 and bit 2 means 0, followed by, because when both these things are true only, AND gate will give you true. When both are false, it's false. Now bit 1 is false, so answer also will be false. Here bit 2 is false, so definitely your answer also will be false. False means I'm taking it as 0, and true means I'm taking it as 1. Now here, if you are coming, both these things are true, so the answer will also be true. Fine. So now what will happen if you do OR operation or gate operations? Okay, so what I will do first of all here is, bit 1 OR operation bit 2. Okay, bit 1 OR operation bit 2. Okay, fine. So now what will happen is that when I do the OR operation of both those things, 0 or 0, I think either one has to be 1, right? So both are 0, so answer is going to be 0. Next, I think bit 2 is 1, so I will be writing it as 1. Here bit 1 is 1, so I will write the answer as 1. Here both are 1, so OR operation also will give you 1. Yes, fine. So what we will the next thing that what we are going to do is, we will see about the XOR operator also. So bit 1 XOR bit 2, bit 1 XOR bit 2. What is the work of XOR operator? XOR operator, if either both the bits are opposite, different bit, then only answer will be 1. Or else if these both bits are same, 0 0, so it will give you 0. Both bits are one same bit, then it will give you 0. If the bits are opposite, different, then it will give you 1. So 0 0 is going to 0, because it's a same bit. Then it's a different bit, so 1. The next one is also same different bit, so it is 1. And finally both are same bit, so I'm going to write it as 0. So this is what the gate is going to do. So I think these gate operation you already know, I think so. So now using this only we will be performing all this bitwise operation. So I'll just show you that. For example, I will take two values called x is equal to 11, and I will take y is equal to 5. Two values I'm taking. What's the corresponding representation of 11? I'll just write only the 8-bit representation. I'm not writing 32 or a 16-bit. Just for the understanding only, I'm just showing this. So we are going to write only the 8-bit representation. Naturally, if you take 11, the corresponding binary representation is 1011. 1011. Okay, 1011. Okay, so but what I have to do is that to make it a 8-bit representation, then I need to convert write all these parts as 0. So this is the 8-bit representation of 11. Let me also take the 8-bit representation of 5. So 0. So I think the 8-bit representation, normal representation, first of all is, it is 101. So this is taken as 1, then this is taken as 0, then this is taken as 1. So all the remaining bit is taken as zeros. Okay, all the remaining bits are taken as zeros. Now if you want to make a AND operation and bitwise operation, you have to do the bitwise. First of all, you take 1 and 1. What is when you what will get when you AND both 1 and 1? You will get the result and answer also as 1. What you will receive if 1 and 0 is AND, 1 and 0 is AND, then the result and answer is 0. What will you get when you AND 0 and 1? You will get 0. What will you AND when you get AND 1 and 0? 0. Again 0. 0 and 0, 0. 0 and 0, 0. 0 and 0, 0. What is the corresponding representation of this 701? The corresponding decimal representation of 701 is actually the decimal number called 1. Shall we check it here in the editor? Actually, yes, we will check once. Okay, so what we are going to do is that we will just have a variable called x, and we'll take a variable called y, and let me assign x is equal to 11 and y is equal to 5. And what I will do is, let me take a z value, z variable, and I'll do z is equal to x bitwise and y expression, and followed by a printf statement where I will have to print this variable called z. So what I will do is, I'll just compile this and then I will just go for the printing the answer. It's printing 1. This is what we expected. Yes, so this is what happens at the background. So we will just go, I'll just go with the OR operation also. Okay, so similarly I will just take instead of 5, let's just be converted into 7, and we will make one more time, we will make it a try. 7 means it is 111, so it is 111 at the end. So if it is 111 at the end, what will be the change? 1 and 1, your answer will be 1. 1 and 1, again the answer will be 1, not 0. 0 and 1, 0. 1 and 0, 0. 0 and 0, all the remaining parts are 0. What is the corresponding representation of 1 1? 1 1 means it is equal to 3. So what will happen here, if I will just go and check here also, instead of 6, let me change it to 7, and let me compile it again and we will check. Yes, we get 3. So it's clearly evident that this is what happening for AND gate. So we'll go with OR. OR means what will happen, either one of the bit has to be 1. So here both is 1, so result and answer is 1. Here also both are 1. Okay, 1. Here one of the bit is 1, so I can take this as 1, not 0. Here also one of the bit is 1, so I can take it as 1. So remaining part, all these things are 2 zeros, so all this thing will remain 0. So what is the corresponding representation of 1 1 1 1? It is going to be 15. It is going to be 15. So just we will go to the editor and we will check whether this is right. Yeah, instead of AND operation we will go with OR operation. So when I do OR operation, what has to happen actually, 15 is the answer. So 11 or 7 is equal to 15. Yes, so 11 or 7 is equal to 15. So now the next thing what we will do is that we will just I'll just show you how to do XOR. What will happen if you do XOR? Okay, we will see what will happen if you do XOR. What has to happen? Both the bits has to be 0. Both the bits has to be different. I think both these bits are not actually cap operator. Okay, so both these bits are not they are both the same, so it becomes 0. Here also both the bits are same, 0. Here the bits are different, so 1. Here the bits are different, 1. All the others are same, so remains 0 itself. So what is the corresponding representation of this? The corresponding representation of this is 12. It's 12. And just we will go into the editor and check if 11 and 7 is XORed, whether we will get 12 or not. That we will check now. Yes, we are getting 12. Yes, fine. So now we will just go for the bitwise NOT operator. Bitwise NOT operator. So for the bitwise NOT operator, what I will do is I'll just take a number called 5 and we will just see it. Okay, we'll just see 5. So for example, I'm just taking only for no two operands. We don't require 2 operands, only 1 operand is enough. So x is equal to 5 is a 1 operand that we are taking. Now what's the corresponding representation of 5? 5 is given with 1 0 1, so it is 1 0 1 is a corresponding representation. When you want to do what you want to do, you want to convert this into the NOT operator. Okay, you are going to do NOT of not of x, what will happen? All the 0 will converted to 1, all the 1 bit called 1 will be converted to 0. So this will become 1 1 1 1 1, and it's going to be 0 1 0. And if you see, I told you already, the most significant bit is called as a sign bit. The red color marked bit is called as a sign bit. Initially it was 0 and now it is 1. It means that before your not operation it was a positive value, and now it is actually a negative value. It is actually a negative value. So now how to identify the corresponding representation, because this becomes 1, right? You cannot directly find the answer decimal representation when your sign bit is 1. When your sign bit is 1, when you want to find the original answer, you have to do the 2's complement. What is 2's complement? You have to make 2's complement. What is 2's complement? All the 1 will again be have to be converted to 0. So again I will convert all the 1 to 0 and 0 to 1. So it becomes again the original 1, and you have to add 1 to it. If you add 1 to it, what will happen? This will become 1 plus 1 0, and the carry will become 1. That carry 1 and plus 0 will make it 1. And then this is same like 1, and this is similar, it is going to be 0, and all these things are going to be like 0 0 0 0. What is the corresponding representation of this after adding 1? This is called as 6. So I will tell you that this number is minus 6. This number is called as negative 6. How we identified? First of all, my not operator, what it does is it changed all the zeros to ones and ones to zeros. And then to find, then the suddenly what happened? The sign bit becomes 1. When sign bit becomes 1, it is a negative value. I cannot directly find the negative value. I should, if the sign bit is 1, to find the original value, I need to do 2's complement. What is 2's complement? Convert back all the zeros to 1 and again 1 to 0 and add 1 to it. That is what 2's complement. So adding 1 to the original value, what it happens? It is giving me 6. So this will definitely be minus 6. This not of x is giving you minus 6. Shall we check it once? Yes. So what I will do is x is equal to 5 I will give you, and I will just give you for x is equal to 5 followed by z semicolon. Z is to store the answer. So what I will do is not x, and what I will do is I will just print z, and we will check what is going to happen. Yes, yes, it is also printing minus 6 as we expected. So this is what the not operator is going to do. What not operator is going to do? It is going to convert all the corresponding 1 bit to 0 and 0 bit to 1. And finally, definitely your sign bit might change to 1. If the original value is positive 0 bit, then the sign bit will be changed to 1. If the original is negative, then it is correspondingly changed to negative, positive. Okay, fine. So now we have finished seeing these operators. Then we will just see about left shift and right shift operator. And the next operator we will be seeing is left shift operator. What is the usage of left shift operator? That I will illustrate here in the same sheet itself. I will just illustrate. Okay. So for example, what I need to do is 1 minute. One minute. Fine. So now what I will do is I have to do I'll take first of all left shift. First of all, I'll just take x value is equal to 5, x is equal to 5 I will take, and after taking x is equal to 5, what is the corresponding binary representation of 5? The binary representation of 5 is 101. So I'll take it as a 8-bit representation, triple 5 6 zeros and followed by 101. And now you have to do y is equal to x left shift to 1. So y is equal to x left shift to 1. So when you're doing x left shift to 1, what will happen actually? 5 left shift to 1. What has to happen is all the bit will be left shifted by 1. For example, this 1 bit will come here. This 1 bit will come here. I'll write 1. And this 0 bit will be moved 1 step left side and this will come here. And this bit called 1 will be moved 1 step left and it will come here. And 1 bit will be moved here. This bit will come here 0, and then the next this bit will be moved to this place, and next this bit will be moved to this place, this bit will be moved to this place, and this bit will go out. This bit will go out. And similarly we have one more, we want one more. What will happen? You don't think that this bit will come here. No, one more extra 0 will be added on the empty space on the right side. So this is how. What is the next left shift? It is not, if this x left shift 1 means this will happen. What is y is equal to x left shift 2 times if you do. What is this? So from this 1, 2 times left shift. So I will take this one left shift value, then I will do one more left shift. So what will happen? This 0 will be moved to here. So we'll start here. This 1 will be moved to this place 1, and this 0 will be moved to this place 0. And this 1 will be moved to this place 1. This 0 will be moved to this place 0, and this 0 have to be moved to this place 0, and this 0 has to be moved to this place it's 0, and this 0 will go out of the scene, and finally we will add 1 0 to this empty space. Okay, so we will see the corresponding decimal representation of this number. We know that the input taken is 5, and what is this? This is actually 10. And what is this? This is actually 20. Can you able to see a pattern here? It is multiplied by 2 every time. 5 multiplied by 2 10, 10 multiplied by 2 20. So it's clearly one thing we can observe is whenever you do a left shift, you keep on multiplying a number by 2. So what I can do is that, for example, you can rewrite this as 5 multiplied by 5, and then next one you can write this as 5 multiplied by 2 power, okay, 5 multiplied by 2 power 0, for example, 2 power 1. Then you can write this 20 as you are multiplying 5 multiplied by, you are multiplying it by 2 power 2. So this keeps on going. So first of all you multiply it by 2 power 0 original number, then 2 power 1, 2 power 2, 2 power 3, 2 power 4. So you keep on multiplying it to the power of 2. So how I can write this? So see here, if the left shift that you are performing is 2, then it is raised to the power of that left shift value is raised to the power of 2. If only one left shift is happening, then 2 power 1. 2 left shift is happening, then 2 power 2. Suppose if 3 left shift is happening, then this is going to be 2 power 3. So I can write a common formula for this. What is a common formula that I can write is, if you are writing y is equal to x left shift k, if you are writing y is equal to x left shift k, then what will happen is your y will be stored with x multiplied by 2 power k will be the right answer for that particular left shift. Yes. So what we have done, we have taken a number, we have done left shift by 1, left shift by 2, and we have taken the corresponding representation 5, 10 and 20. We compared these three things and we found a pattern that those are all multiplied by the power of 2. And we are coming to a general pattern that whenever a pattern like this is given, x left shift any k, can be 1, 2, 3 or anything, that is what I'm mentioning, but k, general k. And when this is happening, then the resultant answer will definitely be x multiplied by 2 power k. Now coming to the right shift one, what the right shift will be doing, again I will do the right shift from here, from 20 I will do right shift. What will happen, this 0 will go to this right side spot, this right shifting, okay, 0 will go to this, this 0 will go to this spot, this 1 will again go to this spot, the 0 will go to this, see this 1 will come to this spot, not 0, okay, the 0 will come here and this 1 will just move here and this 0 will be moved to this place and this 0 will go out of the scene, and instead of this we will add one more 0. And now what is the representation of this, this is 10. So you can able to see this, whenever you do left shift, it is multiplied, keep on multiplying bit by 2. Whenever you are doing a left shift, you are dividing it by 2, you are dividing it by 2. So what you can write is that whenever you do y is equal to x right shift k, when you are doing, then you can rewrite this as x divided by, it is divided to the 2 power I, it is divided to 2 power k. So when left shift multiplied by 2 power of 2, and when it is when it's left shift, then it is multiplied by the power of 2. When it is right shifted, then it is divided by the power of 2. Okay, so we will use this left shift right shift in many places. We have a separate section for bit manipulation, there we will, I'll just tell you the exact usage of this left shift right shift, where we will use, for which kind of problem we will use this operators. Yes, so this is it for this session, and in the next session we will start with the enum and type def. Okay, and in the next session we will also see about enumerator, type def, and we will start with conditional statements, and also we will get into logical operators, and we will see few problems to illustrate conditional statements, and also we'll be seeing about loops also. So up to loops we will be seeing in the next video, and the next subsequent video we will be starting with number crunching. Okay, fine. So thank you, and this is it for the session. And before closing this session, I'll just show you our website, myslate.sixphrase.com, and in myslate.sixphrase.com we are having several courses. We have generic courses like C, data structures, Java programming, Python programming, and we are also having company specific modules also, like for L&T, TCS Ninja, Hexaware, Capgemini, many more courses we are having. So I'll just suggest you to take these courses, and these are having a very structured problem sets are there, along with the solutions also. So you can just go ahead and take these courses and start practicing these courses. Yes, thank you, and this is it for the session. Thank you.